Okay, hello. So today we are going to discuss about petroleum refining techniques, and we're going to start with the physical and then the chemical properties of crude oil. So today we are going to talk about only the physical properties, and then we'll talk about the chemical properties later on. So when we talk about physical properties of crude oil, we are talking about the characterization of crude oil that is used to determine which type of crude oil that we have, whether it's a light crude oil or a heavy crude oil, whether it's a crude oil with high sulfur content. So the physical properties basically talks about, or it tells us how to identify crude oil on visual inspection. So once you see the crude oil, you'll be able to identify what type of crude oil is, what type of crude oil that is. So basically, that's what we are going to do today. Sorry. So we are going to start with the API gravity. So when we talk about the API gravity, the API gravity helps us to know how light or how heavy your crude oil is. And the higher your API gravity, the more lighter your crude oil. And the smaller your API gravity, the more heavier your crude oil become. So as you all know, or some of you know, Ghana, we are having very light crude oil, which means we're having an API, a crude oil with API around 30 or above 30. And in countries such as Venezuela, they have very high crude oil, very high very low API gravity, which means that the viscosity of their crude oil is very high. So basically, API gravity can be determined using this formula. That's 141.5 over the specific gravity minus 131.5. And then the specific gravity of any component can be measured using the weight of the component over the weight of water. So using this formula, you can determine the API gravity of any crude oil that you want. And then this will tell you whether the crude oil is high or whether the crude oil has a low viscosity. And this API gravity also affect the price. You know, companies or refineries, they like crude oil which are very light because it becomes more easier for them to refine, and then they get more of the petrol and diesel. But if your crude oil is very heavy, after refining, you get more heavy products such as bitumen and asphalt, and you get very small amounts of petrol and diesel. So most companies they prefer crude oil which has very high API gravity. That's light crude oil. So that is how API gravity affects the market price of crude oil. So we also discussed about, so we also looking here, this diagram shows the API gravity and then the type of crude oil that you are able to get, or the type of products that you're able to get from the crude oil. So from 0 to 10-degree API, we have heavy oil bitumen. So bitumen is what we use for roads. So you can see how viscous that is. It means that it has an API gravity, which is very low. That's from 0 to 10. And then when you come here, we have an API gravity of 80 to 90, and it shows LNG and CNG. LNG is liquefied natural gas, and then CNG is conversed natural gas, or sorry, condensate. That's natural gas which has been compressed. Okay, so all this shows the type of how API gravity affects the type of crude oil that you are likely to get, or crude oil product that you are likely to get. We also talk about the color. So the color also helps you to determine the type of crude oil that you have, whether the crude oil is heavy or the crude oil is light. So a crude oil with a light brown color shows that the crude oil is a light crude oil. And then a crude oil which is very dark in complexion shows that that crude oil is a heavy crude oil. And then that can be indicated using this picture that I indicated. So you see, this one shows a very light crude oil. So the color ranges from it's very light and then it's yellowish in nature. And as the crude oil becomes heavier, it starts darkening. And this one shows a crude oil which is very heavy. or which is very heavy in nature. So you can see the color is a little dark. So it shows that it's more heavy in nature. So the color also helps us to identify the type of crude oil using visual inspection. So there's no need to go and do any test. So once you look at the crude oil, you'll be able to know whether it is a heavy crude oil or a light crude oil. And the third point that we talked about in our video was the sulfur content. So sulfur is very important because it determines the type of refinery that you can refine a crude oil. For instance, how many of you know that in Ghana we have a refinery, which is the Tema Oil Refinery? But when we produce crude oil, we have to sell the crude oil and then go and buy another crude oil just to refine it. One may say it doesn't make sense. Why? Because how will a country which produce crude oil sell that crude oil and then go and buy another crude oil just to refine? So the answer lies in the type of crude oil. You know, the Tema Oil Refinery was actually established in the 1960s. Yeah, in 1960 by Dr. Kwame Nkrumah. And during um his idea, I think, was, you know, at that time Ghana was in the industrial era, and then Kwame Nkrumah had a vision of making a lot of roads. So the refinery that Dr. Kwame Nkrumah established, that's the Tama Oil Refinery, was basically designed to refine crude oil which is very heavy, or crude oil which has high sulfur content. The reason behind that was when the crude oil is very heavy, you get bitumen as a byproduct, and those bitumen can be used for road constructions. So during Kwame Nkrumah times, he was keen in road construction. So at that time, that idea was valid because you were able to get bitumen and then you will use it for road construction. And at that time too, there wasn't a lot of vehicles being used. So if you go in for light crude oil, you get a lot of petrol. And then who is going to use the petrol, right? So the idea was to get heavy crude oil so that after refining, they'll get the bitumen and then they will use it for road. Now, fast forward. Now we are in 2022. So from 1960 to 2022, Ghana still uses that refinery. And then that refinery I think, has been upgraded only once or twice. And because the initial idea was for it to process heavy crude oil, now Ghana is producing light crude oil, and then we cannot process that crude oil because Ghana's crude oil is light and then it is sweet. So the facilities to process that Ghana doesn't have. So that's why Ghana produces crude oil, sells it, and then go and buy heavy crude oil from another country. So that was just by the way. Now let's come to our topic. So we have sour crude. So sour crude are basically crude oil which has high sulfur content. And normally those crude oils are heavy in nature. And then sweet crude are crude oil which has less sulfur content. And basically those crude oil are light in nature. And then the process for removing sulfur from crude oil is called sweetening. So we'll discuss that in our upcoming topics. So we'll go into sweetening and then how sulfur is being removed from crude oil. So basically, the sulfur content helps you to know the amount of sulfur which is contained in crude oil. So from that, we moved on to the viscosity. So we know what viscosity is. So viscosity is the measure of ease at which a fluid flow. So viscosity is also very important when it comes to crude oil, especially during transportation of crude oil. So for example, if you're having a crude oil which is very viscous in nature, it becomes very difficult for you to transport that crude oil through pipelines. So it means that the crude oil, which is viscous in nature, you cannot transport that crude oil through pipeline because you would need a lot of energy in order to transport that crude oil. But the crude oil, which is very light, it will be easier to transport it through pipeline. So as a petroleum engineer, looking at all this property, it will give you an idea on how to transport your crude oil. So you can use tankers or you can use ship to transport such crude oil. That's a crude oil which is very heavy instead of using a pipeline. So these physical properties of crude oil gives you various ideas of how to process the crude oil, how to transport them, and then what product you get from those crude oil. So here, this is called the viscosity also. So let's go to a slide and read something small. So for crude oil, viscosity depends on the amount of gas dissolved in the oil at a given temperature and pressure. The property is used, the property is useful to know the reasons for crude oil transship and pipeline passing. So that's what I explained earlier on. So enough about the viscosity. Now we'll go to the cloud point and then the pour point. So this explanation might be a little similar to the viscosity explanation, but I'm going to explain it in such a way that you understand. So if you're having a crude oil and then you pass that crude oil through a cold process or you cool that crude oil, a substance begin to occur in that crude oil. That's a cloudy substance begins to occur in that crude oil. So at the temperature where that cloudy appearance happens, as you can see in this on your screen, you see a cloudy substance starts occurring. So the temperature at which that cloudy substance starts occurring, we call that your cloud point. And then upon further cooling, now your crude oil will cease to flow. So the temperature at which the crude oil ceases to flow upon cooling, now that temperature becomes your pour point. So one might ask, how is this important? So for those of us who use car or who are about to buy car, the car runs on an engine oil. So if you look at the engine oil, it shows you the type of oil that you use. Some of them will write maybe 0W20. So the 0 is the viscosity at 0 degrees, and then the 20 is the viscosity at 20 degrees Celsius. So it shows you that the car can run, it shows that the oil can run in cold regions of up to 0 degrees Celsius. So an engine oil with, let's say, 5W40, it means that it can run within the temperatures of 5 degrees and then 30 degrees Celsius. So if you are in a place like Iceland, it will not be advisable for you to use an engine oil of, let's say, 1040, because that place has colder temperatures. So you have to use a crude oil, which is maybe 020. Sorry, an engine oil, which is 020. Now, the reason why you have to use engine oils, which is 020 in colder areas, is that if you use a crude oil which has low, like its tolerance is very low when it comes to temperature, as you are running the engine, the crude oil is going to become viscous. That's as a result of the pour point. So your engine oil will become viscous, and then your engine will not function properly, or your engine will get damaged because it's not working within the viscosity at which that engine is supposed to flow. Like let's say they tell you to run in mud. Like let's say you're having muddy water, and then they tell you to run in it. It becomes difficult for you to run because of the high viscosity of the mud. So it drags your legs. So in the same process, if you are using an engine oil which has a very, let's say, high pour point, your engine will not be able to run efficiently. So determining this pour point is also very crucial in the type of engine that you use and also in the transportation process. Because if you are transporting crude oil in a cold region and then the pour point is very high, it means that the crude oil is going to solidify along the way in the pipe. So it's also very important to know the pour point and then the cloud point of crude oil. And then our last but one talks about the ash content. So the ash content also talks about the amount of impurities or metallic substance in your crude oil. So we all know that crude oil contains a lot of substances. We have sand in it, we have metals, small traces of metals in it. We have other components. So in order to, like, if you want to sell a crude oil, you need to determine the ash content. So the ash content will let you know the amount of impurities that is in a crude oil. Like, for instance, no one wants to buy a crude oil which has maybe 20% of sand. It means that the crude oil is only 80% and then only about 20% of sand. So this ash content lets you to know the amount of impurities that is found in the crude oil. So how do you determine the ash content? So the ash content, you pour your crude oil in a crucible and then you put it in a furnace and then heat it. So after the combustion of the crude oil, a residue will be remain in your crucible. So that residue is being collected and then is being weighed. So the weight of that residue tells you the amount of impurities that is found in that crude oil. And this is also important because it helps you to market your crude oil. So if there is a lot of impurities in your crude oil, the price of that crude oil will go down. And also it helps the person buying the crude oil to know which type of refinery he's supposed to refine that crude oil in order to avoid any damages of equipment. So this is an example of the ash that is being collected. And then the last point for today, we are talking about the flash points and then the fire point. So I hope everyone have seen that, like, if you go to a filling station or a place where they sell um, gas, they write highly flammable. So the question is, how do you know that substance is highly flammable? So it is through the flash point and then the fire point. So the flash point and then the fire point will let you have an idea of how flammable your crude oil or your crude oil product is. For example, a gas has low flash point as compared to petrol, and petrol have lower flash point as compared to diesel. So what that means is that if you're having a gas, so if a substance has a low flash point, it means that it is highly flammable. So let's say that you are having a gas and then you light a match close to that gas, instantly it will catch fire. In same way, if you're having a petrol and then you light a match and then it is close to that petrol, it might not catch fire unless maybe you bring it a little closer before it will catch fire. In the same way, if you're having diesel, the tolerance the probability of it catching fire if a heat source is close to it is very low, unless that heat source or that source of ignition is right, or you put it right into the petrol or the diesel. So the flash point gives you an idea of how flammable your crude oil product is, and which is also very important. And another example, those who use car or those who know people who use car, some people will tell you that they went to the filling station to buy fuel and then they pumped only gas into it. Now, those people, are they right or they are wrong? So one can argue if you know how the flash point and then the fire point works, or the flammability of crude oil work, you might agree with them. Because if you go to the filling station in a hot afternoon and then you want to buy fuel, because the weather is hot, you know, the crude oil product, let's use example the petrol, it is bonds that is holding them, right? So let's petrol has a chemical, it has a range of C6 to C10. That is the carbon range of C6 to C10. So once heat is being or once it's being affected by heat, the bonds begin to break into C1, C2, C3, C4, which are gases. So in that extent, if you buy the crude oil at that state, it has the likelihood of turning into gas. So they will fill it and then the meter will read. And then it will read as they are pouring petrol in your tank. But in essence, most of that petrol is in a gaseous state or it is close to a gaseous state. So once it gets in your tank, and then let's say your tank, it's having a leakage or it's having a hole in it, everything will just evaporate. So people who say that they go to the filling station to buy petrol and then they give them gas, well, they have a claim to that. They have a claim or they have um, a right to say that. So I always advise people that if you want to buy petrol, you go there very early in the morning or very late in the evening. For that one, the temperature has come down. So any petrol which is in a gaseous state will be able to condense into its liquid state. And then you can buy it without any problem. So I think we've dealt into this enough. Does anybody have any questions so far?
Yeah. Okay,
Yes,
sir. Yes.
yes, please.
From your previous class, I think I made some research and I got to know that concerning the conventional diesel, there's also another component called biodiesel.
Yes,
And I got to know that they have certain similarities in terms of cloud point and pour
poor
point
point. Yeah,
and also flash point.
yeah.
Yes. Can you throw more light on the differences between the cloud point of the biodiesel and how different is it from the conventional diesel, please? Thank you,
Oh,
sir.
okay, okay. So the flash, you're talking, I talking about flash point, right? Or the cloud point?
Pour point. The cloud point and the pour point.
The cloud
Since
point and then, yeah,
pour points, pour points.
yeah. So um, biodiesel is essentially made from oil. It can be an organic oil or an, sorry, it can be an edible oil or an unedible oil. So let's take an oil like Frito, right? You can do this,
Yes.
you can do this experiment yourself. You buy Frito oil and then you try to pour it when you've not put it in the fridge, right? Just try to pour it and see how the flow is going to be like. And then you put it in a freezer for like about an hour, and then you pour it and then see the change in the two. You see that
Okay.
after you put it in the fridge and then you try to pour it, it will come very slowly. You have to turn the whole bottle before it will be able to pour, right?
Okay, sir.
So that indicates that the friter has a very high pour point. Now
Okay.
comparing, let's say, like you've made biodiesel out of that friter, it is still going to have that property. The cloud point
Yeah.
and then the point is still going to have that property. So it means that this biodiesel, let's say, if you want to use it, you cannot use it in a very cold region. If you want to use it in a
All right.
region, you have to use maybe a different oil. We're having oil which is very viscous, in oil which is very light.
Yes,
Like
please.
the
Yes.
same cooking oil. Like if you take sunflower oil and then you compare it to maybe an oil which is made from animal fat, you can see that the sunflower oil is very light, or it's less viscous as compared to the oil which is made from animal fat. So let's say that if you want to use biodiesel in colder regions, you have to consider the type of oil that you use. The oil has to be very
All right.
light because it normally retains that same property. That's a poor point. And then, yeah, I hope I answered your question. Oh,
Yes, please. Yes, please. I'm very clear now. Thank you, sir.
okay. Does anyone also has any question from relating to the
Hello,
property?
sir. Please check your chat.
Oh, okay. Sorry. Um, okay. Okay, I should share my slide. So I'll share the slide at the end of the meeting. And one also asks, which acid is used in petroleum refinery industry and why acid? I don't understand that question. You said which acid is used?
Okay. Yeah, I think I was reading one book and then they were saying hydrofluoric acid is used in the refinery.
For
The catalytic processes
catalytic
like,
cracking.
yeah.
So in the
When I was
yeah, so in the catalytic cracking, we'll be discussing it in along the way. So in the catalytic cracking, they use catalysts. Okay, so I haven't heard of any acid. Maybe that catalyst can be acidic in nature, but not necessarily acid. So,
okay.
so they use catalyst in helping to break down the crude oil into lighter components. You know, before the crude oil gets into the catalytic cracker, it must first go to the atmospheric distillation unit, the vacuum distillation unit, then it will go to it will go to the reform.
Hello?